The one thing that I feel I don't know how to teach because it seems so obvious to me is, just being in love with it, being in love with chemistry. Because I don't understand if somebody comes to me and says, what's my motivation here? Or, what? I can't, if you don't know, because again, nobody's forced anybody to become a chemist. This is a path that we choose. I'm going to try to explain what my research is about and how I came about some of the discoveries that my group and I made together. Really what's inspired me throughout my career is that chemistry is useful, but it's also interesting at a fundamental level. So catalysis it's actually one of the few terms in chemistry that has a purely good connotation. When you say catalyst, that always means something positive, bringing people together. And catalysis is a good thing, even at a chemical level. The kind of catalysis that I'm interested in is kind of a peculiar one. This is a catalysis that involves the fact that almost all of the molecules of life are handed. So when they interact with one another, it matters which hand you have. And therefore, there's enormous interest in figuring out ways to synthesize handed molecules, not as 50-50 mixtures of the two, but as a single hand, a left or a right hand. And that's the field of asymmetric synthesis or asymmetric catalysis. So what I'd like to try to share with you are some of the reactions and some of the catalysts that we developed with a lot of surprises and a lot of unexpected turns that have ended up being especially exciting.
I think he's sort of instrumental in teaching people how you can control the course of a reaction, and he sort of inspired several generations of scientists, and that changed the way organic synthesis is done.
There was a disconnect between developing of practical synthetic methods and the studying of catalysis in physical organic chemistry, and what he did was he put them together. He gave people sort of a roadmap about how to do it.
He burst onto the scene with discoveries that were really sort of dogma busting. He really became one of the must-read scientists out there.
A big hallmark of the way he approaches his science is that he's not kind of just content to discover a reaction and use it for things. He really wants to understand how it works.
Eric is really focused on, why something works and how something works, but also is, I think, really attuned to impact. What makes something an important reaction and not just a sort of curiosity.
And he has this ability to immediately see what is unusual, this set of observations that doesn't make sense. And as he'll say, this result is trying to tell us something.
I think Eric really loves to understand how things work. That could be dynamics between people or the reactions coming out of his lab.
He's been a fantastic mentor and PI. He's available and he's there, but he also gives us freedom and space to kind of do our own science. And I think for me, that's ideal.
He's really a master physical organic chemist, really interested at the level of mechanism and providing both experimental and now also computational evidence for how these things work.
I think the earliest application of Eric's work was in the 90s. So HIV was raging, and Merck had a compound called Crixivan. One of the pieces of Crixivan, an approach to make it, involved a Jacobsen epoxidation, so his eponymous first reaction.
So this is what became known as the Jacobsen epoxidation. We were really thinking about this problem at a very fundamental level. There were fundamentally interesting questions with catalyst design, but nothing could have prepared me for this.
And I think it was a wonderful demonstration that the work, the basic research that happens in an academic lab can be applied in an industrial setting.
Because Merck had this interest, they applied it, and within, as I said, within just a few months, they carried this out on 2,000 kilogram scale. And there's something, it's just a different universe to see chemistry carried out on that scale compared to in a small flask in the laboratory. So it was the most gratifying and exciting thing you can imagine.
So this was really, I think, what made Eric Jacobsen to start, but it just doesn't seem to slow down. He went from there into what we call the Jacobsen hydrolytic kinetic resolution, was really something that when it came out, 1997 or so, I think took everybody by surprise.
I think very few people would have had the success that Eric had in oxidation chemistry, and then essentially move completely into this other area where he has, done really groundbreaking work in a number of different things.
There's a whole bunch of these different sort of landmark discoveries. The idea that small interactions, long covalent interactions like hydrogen bonds, can actually be sort of in aggregate strong enough to control reaction pathways so that you can achieve a similar level of selectivity. Also really, I think, groundbreaking, but again, something that we completely take for granted. So again and again, he's sort of reset the where the ground is, I think, for our field.
There are a few moments I've been fortunate to have in my career where I've sort of had a strong sense that what we're looking at is important and I don't understand it at all. And that is my favorite feeling, because these are sort of been moments where I thought I could spend the rest of my life thinking or working on this problem.
They're brilliant scientific contributions, but they're also born of a culture, born of curiosity, born of an open mind, born of dedication to mechanistic understanding, and I think also born of a commitment to mentoring and pedagogy. We create these micro-environments in our laboratories that really, I think, are so critical to inspiring the science we do, but also the next generation of scientists.
The lab was a place where you could be yourself, and that's really important. I think that's critical to building a healthy lab culture. People will do their best science and do their best work when they feel like they can be themselves.
I think this is not an accident that someone like Eric has been such a great advocate for women and other people from underrepresented backgrounds. But if you ask me to put my finger on what it was, I spend time almost every day thinking about what was it about this environment? What was Eric actually doing, right? That created an environment where people from all sorts of different backgrounds could work together, and where we were all sort of working together for really to achieve research excellence.
When you think about the impact broadly on the field of organic chemistry from a practical perspective, from an intellectual perspective, you think about his dedication to training, teaching, and mentoring. I can't think of a better awardee in organic chemistry than Eric.
When you think about who are the best, absolute best people in chemistry, Eric's name always rises to the very top.
From the very start, I never took for granted what kind of trust a student is putting in me when they join my group. As part of our recruiting of new graduate students, we give a short presentation. We call them an open house, where I talk about the research that the group is doing, and all of my current group attends. And so I give presentations about 5 years ago. Final slide was a picture of the group. I remember the words coming out, and I was surprised that they came out. And I really love these people. That was truly spontaneous. I had not planned to say that. But I do now realize that really is the word. So I do feel great love for the people that I've worked with. They threw a birthday party for me when I turned 60, and students from all over the world, who are now in different places came. And by this time, everybody sort of talks about this. When they all come into one room and say, this is ridiculous. Look at all the people who've been in this group. A lot of people would say, I feel very lucky. And obviously I do. But mostly, actually what I really feel is incredible love for my former students. And I know that sounds ridiculously cheesy, but it's absolutely sincere. That was the other thing that struck me about this celebration. I almost didn't need to be there. They were just excited about talking to, seeing each other and different generations of students meeting each other. I was, maybe there, maybe I was just sort of like a catalyst on the edges. but it was a beautiful thing to see.